angles of elevation and depression. We are still using sine, cosine, and tangent. Okay, but we're going to have to read the question. Then we're going to have to represent it in a picture and then determine, are we going to use sine, are we going to use cosine, or are we going to use tangent based off of the picture that we have. So when looking straight to an object, okay, that's the first word, is straight. The angle of elevation, to elevate, what does that mean? Go up or down? Up, okay, so when we're looking at angle of elevation, we're going to look up. So when looking straight to an object, the angle of elevation is formed by an observer's line of sight, okay, and a horizontal line. So what that means is, let's say I want to look at this projector up here. It's in the middle of the screen. My line of sight is a horizontal line. Does everybody agree with that if I'm looking straight ahead? My angle of elevation is going to be the angle that is in between this horizontal line and the angle of which my eyes are going. So do you see what my angle of elevation looks like? It's going to be this angle right down here against my chest, okay? So from my straight line of sight, my horizontal line, up to whatever it is I'm looking at, that's where the angle of elevation goes. So when we are representing these in a picture, it's going to be in one of two places, and it depends on how you draw your picture. First of all, let me put this up here. Just remember. Okay, so you'll either have a picture that looks like this, and your angle of elevation is going to be this angle right here. Or we're going to turn the picture around, and my angle of elevation would be here, okay? So either way, it is the angle coming from the horizontal line going up to whatever it is I'm looking at, okay? From a horizontal line going up to. So it will be the angle down here at the bottom. Does that make a little bit of sense? All right. So we have to, first of all, read the question, and then we have to draw a picture. And it doesn't have to be an artist's picture. It just needs to be a representation of what we're talking about. So let's take a second and read that first question. Okay, go ahead and read your first question. Okay, Casey sights the top of an 84-foot tall farmhouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? Okay, we're going to basically, when they tell you how tall somebody is, we just imagine that their eyes are at the top of their head. Okay, we're not going to think about the inches that you have between your eyes and the top of your head. So what we're going to do is we're just going to start with Casey. Okay, there's Casey. See, I'm a really good artist, right? All right, now Casey is looking straight ahead. That's his horizontal line of sight, or hers. I don't know if Casey is a girl or a boy. It doesn't really matter. And then you have your lighthouse over here. There's my lighthouse. And then Casey is looking at the top of the lighthouse. And my lighthouse and my person are not proportional, okay? They are not drawn to scale. We have to imagine that. That person is not almost as tall as an 84-foot tower. Okay, do you see how I have a triangle up there? Okay, so the first thing we want to do is label everything that it tells us. What does it tell us about the height of the lighthouse? Sorry. It's 84 feet. So 84 is going to go over here. And then it tells us that the angle of elevation is how much? 58. So 58 degrees is going to go right here in between his horizontal line of sight and up to where he looked at the angle. And then what it is asking is how far is he standing from the base of the lighthouse? So in my picture, which line is the distance from him to the base of the lighthouse? Is it the blue horizontal line or the green diagonal line? The blue one. Okay, so that's what we're looking for. So we're going to call that one X. Now, before we can actually set this up, we need to think about something. The entire lighthouse, the total lighthouse is 84 feet, correct? And Casey is how many feet? 6. So how many should I take off of that lighthouse to make it right? 6. Okay, so what we're going to do is we're going to focus on this part right here, this triangle right here. Okay, and I'm going to come over and draw it to the side. This is my 58 degrees. This is the side we're looking for. That's going to be my right angle. So if I do that, if I take the entire lighthouse, the 84 degrees, and I take away Casey's 6 feet, how much is left? Come on, 78. If you don't have one, you're going to need one. So right there on that vertical line, on that red triangle, the one with your side, go ahead and put 78. So the 78 is going to go here. Does everybody understand where 78 came from? We had to take away his 6 feet out of the height of the tower. Now, we're going to do exactly what we did yesterday. Look at your picture. Determine if you are supposed to do sine, cosine, or tangent based off of the sides that you have labeled in your triangle. Okay, the red triangle, not the picture with the person in it. Do you have opposite? Do you have adjacent? Do you have the hypotenuse? Determine which ratio you're going to use. Okay, quick question. In my red triangle, do I have the hypotenuse labeled? No. Okay. So in reference to my 58 degrees, where is 78? Opposite. And where is X? Adjacent. Okay. So what I need to determine based off of SOHCAHTOA, which ratio am I going to use? Sine, cosine, or tangent? Which one? Tangent. Okay. So now we can set it up just like we did yesterday. The tangent of my angle, that's 58 degrees, is equal to opposite over adjacent. If you're not sure, it says it right here. Opposite over adjacent. O over A. Opposite over adjacent. Which one do we have labeled as the opposite side? And then my adjacent side is X. I want you to continue to solve this just like we did yesterday. The only difference is we actually have to draw the picture. They don't give it to us straight away. We have to draw it and label it in order to be able to determine what ratio to use and what to set up. Our test on this stuff is next Tuesday. There are a lot of people who aren't really trying on this, which tells me that I'm going to have a lot of people not doing very well on that test. I am trying to make this as easy as I possibly can. Cross multiply. Remember that X is going to go in front of the tangent. What do I need to do to get X by itself? Divide by tangent of 58, yep. So those are going to cancel. And then it's directly to the calculator after you have it solved for x. You're going to do it exactly as it says. 78 divided by the tangent of 58. Zion, your calculator is what we call is backwards. So when you do it, you're going to hit 78 divided by 58 tan equals. Okay. All right, so 78 divided by the tangent of 58. Let's round it to the 10th place. 1 decimal point. Do that in your calculator. 78 divided by the tangent of 58. And tell me what you get. Thank you. You should get 48.7. It's 48.73. That 3 tells me that the 7 is going to stay the same. So you did 78. And then 58. Yeah, you don't do second if you know the angle. Okay. That makes a little sense. Everybody right? Yeah.
So if you were to, let's say 64, 28.73, if we were to include that 3, would we get marked off of that?
If I told you to run to the 10th place, yeah.
Okay.
So just pay attention to how it plays around. All right. Ready? Take a minute, read question number 2. The angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? Okay, so we've got a person and we got a goalpost. Everybody ready? All right, so I'm going to draw my person, my kicker. And then I'm going to draw my goalpost. Where do you kick the ball from? The ground, right? Okay. So it says that he is standing how far from the goalpost? Okay, so down here at the bottom, that's going to be 131 feet. And then it says his angle of elevation to the top of the goalpost is how many degrees? 17. And it's wanting to know how tall the goalpost is. So what do I call the vertical part over there? X. Okay, now remember your goalpost is going to form a right angle with the ground, correct? So what you need to do now that we have our picture set up, sine, cosine, tangent, and then set up the problem, work it out for x. In reference to your 17 degrees, what 2 sides do you have? But what are they? Are they opposite, adjacent, hypotenuse? What are they? Opposite and adjacent. Okay, x is my opposite side. 131 is my adjacent side, which means what ratio will I use if I have opposite and adjacent? Tangent. Okay, so let's set it up. It is the tangent of my angle, which is 17 degrees, equals my opposite side, which we called x, over my adjacent side, which we called 131. Put that tangent of 17 over 1, cross multiply and solve, go to your calculator, round it to the 10th place. Cross multiply, x times 1 is x. Remember, when we multiply a number by a sine, a cosine, or a tangent, it goes in front. Do I need to do anything else to solve for x there? No. Okay, it already says x equals. Now I can go straight to my calculator. And I can do 131 times the tangent of 17, rounding it to the 10th place. Ronald, what'd you get? 40.1. Make a little bit of sense, kind of, sort of? All right, I want you to try 3. Read the question. Try to draw your picture. See what you can do. Let's see about how we can set this up. Think about what a slide looks like. Draw your picture. Think about where everything goes. Where you like, you make your list, where you use some Where's your slide? Think about how your slide goes. When you have a slide, does it go straight up and down? Does it go flat? It goes at. So that would be what your slide is. Does that make sense? You got to visualize. We've all played on a playground before. So you have to hit the number first. This number times 17. Yeah, you got the whatever's next to the sine cosine. You do that first, then sine cosine. Think about a slide. Okay, not a fancy slide, just a regular old slide. Yep. Think about a slide. What shape does that form technically? A triangle, okay. Now it says Leah's mom is standing at the bottom of the slide at the playground waiting for her to slide down. The angle of elevation from the bottom of the slide to the top is 46 degrees. Remember, angle of elevation always goes at the bottom, okay, depending on which way you drew your line. It's going to be either here or here. So I'm going to put my 48 degrees down at the bottom. Then it says the slide has a vertical height of 9 feet. Which way is vertical? Straight up and down. Okay, so I'm going to put the 9 here. What it is asking for is the length of the slide. Is a slide flat?
No, it's like a down.
It's like this, right? So which one of those should I label? The top or the bottom is X? The top. Okay, that's my slide, right? Now, you have your picture. Decide, are you going to use sine? Are you going to use cosine? Or are you going to use tangent? Oh, it's 46. I wrote the wrong number. My bad. Should be 46, not 48. I wrote the wrong number. So in reference to our angle, what two sides do we have? Do we have opposite? Do we have adjacent? Do we have hypotenuse? I need at least two of them. Mm-hmm. 9 is my opposite. X is my hypotenuse. What ratio uses opposite hypotenuse? Sine. So we're going to set this up. The sine of my angle equals my opposite side over my hypotenuse. We need to continue. Putting that sine of 40x over 1. Cross multiply. When I do that, is x by itself right now? Nope. What do I have to do to get it by itself? Divide by what's next to it, which is, excuse me, the sine of 46. So x is going to equal 9 divided by the sine of 46. Now I'm ready to go to my calculator. Rounding it to the tenths place. How long is my slide? 12.5, is that what you said? Okay. Did everybody get 12.5? Well, we clearly do not have enough time to do angle of depression, which is on the back today, so you're going to hold on to those.